Okay, now that's in trigonometry, we are going to see the part that is called, that deals with the angle of depression and the angle of elevations. These ones are helping us in calculating the length of buildings and so on. So please don't forget to subscribe to the channel. Okay, let's go through this. The angle of elevation is an angle above the horizontal made when seeing an object upwards. So when you see, look at my eyes, when I sit up, there's that angle. If this is the horizontal, there's that angle I make when I'm looking up. That's what we call the angle of elevation. And the angle of depression is the angle below the horizontal axis made when seeing an object downward. So if my eyes are up direct to that, then when I look down like this, I'm making an depressed so that I'm putting something below. So that angle we make from the horizontal when we put our head down to something down is what we call the angle of depression. Now, you see, if this is our horizontal axis, always for angle to elevate, you elevate. So it's going to be from the horizontal a certain angle up. Then to depress, you are going below. So start from the horizontal, we start always from the horizontal, then you are going below so that you are seeing something down. Then, or you can be here and then you see something up. If you see something up, you are making an angle of elevation. This is now our horizontal axis, and it's the same as this. When I'm on this, then I see something below, meaning I'm going to make an angle of depression. So from here, if these two are horizontal axes, it means that if the angle of depression and the angle of elevation are the same, so this angle is equal to this angle. Now, let us see some examples. The angle of elevation, here you need to note the words from. So, we need also to sketch the angle of elevation from a point A. So, this is my point A. The angle of elevation, of course, the moment you see that, we are going to see elevation, we are elevating. But, of course, there is a horizontal axis. So, the angle of elevation from A to B. Now it means that point B is somewhere up there. Some point B somewhere up there. Now we are elevating. So meaning our angle is going to be up there. So the angle of elevation means that I'm looking up. So meaning I'm turning my head upwards. The angle of elevation from here, I think that's like it's 45 degrees. Now they are asking us, find the angle of depression from B to A. Meaning that if this is up, to look down to A, it means that it's going to lower the angle. So, remember, if this is our horizontal axis, even at B, it has the same horizontal axis. And these two are always parallel, like that. So, meaning, if this angle here is 45, it means that also this angle here is going to be 45, and so there our angle is 45, the angle of depression. Now, from there, you see that always without this is the same as that, using even this property. That the angle here is the same as the angle here, if this is the horizontal. Now, we are going to apply this idea to some questions, then we shall see the other. Use the diagram below to find the angle, theta, and the length AB. So this is our length AB. And this is our angle theta. Now, because this is here, this is our horizontal, it means that this angle is the same as that angle. So there, our theta is equal to 50 degrees. As simple as that. Because this angle is said that it's always equal. This angle is always equal to that angle there. Now they are also asking us find the length AB, our length AB here. So what are you going to use? You just pull out your saw, this Sokatoa, you now stand for sine opposite of hypotenuse. Cos adjacent hypotenuse. Tan opposite of adjacent. Now, I need this, I have this. So meaning what am I going to use? I have the angle, my angle is only 50 there. So meaning from here, if I have the opposite, I need the adjacent, I have the angle there, I'm going to use tan. How? So that my tan theta, tan of this angle is going to be the opposite over adjacent. But our opposite from here, you see that it's BC. It's BC over the adjacent, which is B. So now we start our tan, 50 degrees, our theta is 50. BC is 10, the whole over AB, which we want. So that from here, I can just get my AB as, if I cross multiply, I divide, I have 10 over tan 50 degrees. And now my AB will be, now you give your answer to 4 decimal places. So now I'm getting 8.39 meters. So if I'm rounding off, that's what I get. So that length AB is that. Really easy. We just use Sokatora. When you come this down here, we are going to learn the concept of sketching. A ladder makes an angle 25 with the wall. So it means that we have a certain wall. Now, I start by doing that. Let me consider that I have a wall there. I have my wall somewhere here. This is my wall. Of course, from the wall, we have a horizontal because any building is sitting on a flat. So, this is going to be the case. So, that means you can show that this is a wall. This is my wall there, like that. I have my wall there. Or, you can leave out that. Okay. Anyway, you can do that so that this is the wall, just to make it practical. So that is my wall. A ladder, and so this ladder, of course, the ladder has to lay on the wall. So it means that it lays when it's touching the ground, then here. So if this is my ladder is going to be up to this wall there. So when it touches this wall, it makes an angle of 25 degrees. 25 degrees. A ladder makes an angle 25 with the wall. This is the wall, this is the ladder. It makes an angle of 25. The wall with the wall 8 meters high, meaning from here up to here we have 8 meters. That's how high that is. And then they are telling us how far is the foot of the ladder from the wall. So if this is our foot of the ladder, and this is going to be our wall, it means that now they want us to get this distance. But now, you see, the only way you can get this, there are two ways. Now is that if I use this, I can get this, then using this. Or I get this angle here, then I use this over this. It's up to you. So what I'm going to do, I'm going now to use this, let me call this one point T. So if I did this, I have this, I don't have this, and I have the angle. So from there, I'm going to use tan. So it's that my tan of the angle, theta, is going to be the opposite over the adjacent. Now my opposite from here, my opposite is going to be that FW over the adjacent, which is WT, using that idea. So my angle theta from here is 25. So now my tan 25 is going to be my opposite, which is FW over the adjacent, which is 8. Now here we want to get the length, the foot from the wall. So that's why I'm interested in this, because it's the length. So it's that here my FW is going to be 8 and 25, and this will be pressed on the calculator. So my length here is 3.7305. Now meters, give 4 decimal places. Now I'm not showing another alternative, but let us first complete this question. Now we're telling us that also find the length of the ladder. Our length of the ladder is FT from here to here. So what are we having? We have this angle, we need this. We have this angle, we need this, we have this side. So meaning there we are going to use cos. We have the adjacent, we need the hypotenuse, but we have the angle. So from there, using the Sokatora, our Sokatora is that from there, my cos theta is going to be the cos theta. Now I have the adjacent. Because our cos theta is given by adjacent over hypotenuse. The hypotenuse is what I want. Hypotenuse, which will be my adjacent is adjacent using this angle. My adjacent is this 8 over my hypotenuse, which is the length of the ladder, ft. Now, from there, you can okay, my adjacent, let me call it wt, so that I substitute at once wt. So that now my cos 25 degrees is going to be wt, which is 8 over ft. And from there, start, if I make ft the subject, I'm going to be having my ft equaling to 8 over, then I'll divide this beside cos 25 degrees. And so my ft here is the length of the ladder. You get 8 divided by cos 25. Cos 25. And the answer I'm getting is 8.827 meters. So this is their length of the ladder is 8.827 meters. That's it. Now the alternative here, the alternative I can use alternative. This alternative I'm going to work it with this arm. Now, you see, when we have this triangle here, this triangle, let me draw it here. If I have this triangle here, I know that here we have 8 meters, but I know it is an horizontal. So if this is 25, mean that this arm is going to be, you know, there, and that arm is going to be 90. So we are going to get 29 minus 25. There we shall be getting our 65 like that. Because when the add this and this will be 60. And then 9, so this one will be now 65. Now meaning, to get now this, you could say, you go and say, now your time 65 will be now the opposite, which is 8, over the adjacent, the length you need, FW. This is FW, FW. And there, FW, your FW is going to be now 8 over time 65. And there, the answer will be having is your FW will be. When you press that, you get 8 divided by tan 65. And so my answer is 3.73 0.7305 meters. And it's the same, you see, it's the same what there. Then the same idea you can use. And now, if you want this F, this was T. So that my F is going to be now, this is the adjacent, I mean the hypotenuse. This is the hypotenuse you want, and you have the opposite. That way I can use sine. So sine 65 will be the opposite, which is 8, over the adjacent, which is ft. So now it's that your ft will be now 8 over sine 65. So now your ft will be now 8 sine. This I'm getting 8.8 to 7 0, which is the same as that in minutes. So it's up to you. So the idea I use will give you the same thing like there. So here we use the idea that all of this angle is 9. So if you have this as 25, the balance is going to be 65. So that's it, members. So you are going to see my examples. I wish you well, but you shouldn't forget that always this is perpendicular.